I thought I'd make an intriguing title here, stuff that makes it work. The rest will mostly be on concepts and hardware and networking. So somewhere in between, this is the part where the PackSoft. So it's interesting to be the first one here. My name is Eelco van der Wol, like said, and now I'm going to check if that yes. A couple of slides, only 3, on PLCopen. PLCopen is an organization that tries to drive forward the efficiency and automation by harmonizing the programming languages and adding some more to it. We are not new. We started in 1992, so we are 20 years there. I put even a 20 years brochure there on the table. There's some information on it, separately from the presentations. So it started basically in the EU, but we are now also in, of course, the other areas here, Japan, China. It started more with the certification, but we start immediately adding things like motion control and safety, and I have a slide on that one. Like said, we are an international organization. We are headquartered in Europe, in the Netherlands. That's where I come from. And we got an office in North America here, and that's Bill Leiden sitting there is running that one. And we got an office in China and Japan. So, the current description of PackSoft is develop guidelines for machinery programming languages to ease learning, support transportability of software across platforms, and allow continuing innovation. That's a nice one, isn't it? So, to give it some body, some hands and feet, first of all, let me go to this one. I can go back to. What we are looking to is in the whole, let's say, triangle, in which way ever you want to have this, we're somewhere here down under. This is where we are looking to. And we're looking up with the communication functions there. But it's specifically more here and there. So if you position PackSoft then in the middle of the rest of the group, there are areas of overlap, of course, between PackSoft, that's the software part, and the other groups that will be shown you after me, PackSafety, PackConnect, PackAdopt, PackML, PackLearn. I hope I have the good names. Yeah, and so in order to keep this working, and we can do a very practical approach, and that's where we're aiming to. We're aiming to use the resources within the organization, the association PLCopen, as much as possible. First of all, to increase the speed of the specifications. The work is a lot of work is done, and to increase the speed of the implementations, because there are a lot of members to PLCopen that are suppliers in this community. So what does that bring? Much work is done. I'll show you some of the work where we are. It's well implemented, it's well known, it's widespread in that sense. There are a high number of suppliers. That means you have many suppliers or many packages to choose from, which brings you to the option of the best of breed. Selection is on your side, if you are the user side. Now, if you look to the different layers, if you look to the whole package, you can identify different layers. And I do not incorporate all the groups, because there are groups that are more showing the advantages and what it all brings. But if you overall look to a way you can deal with it, on top you got the state diagram, and that gives you, of course, the access to the overall equipment efficiency, OEE. And that you can map. And under that one you get the high level, if you look to packaging, the high level functionalities like cutting, sealing, filling, capping, which consist, of course, of smaller entities, smaller objects. And they are based on the basic Lego building bricks in this case, either from IEC 61131 or from PLCopen. So you get the nice layered structure in that sense. And of course you can create from the basic function blocks, the basic functionalities, those functionalities that are dedicated to your machine and your area, and the way you deal with the mechanics, etc. On top, you see this state diagram. Now, this is, according to me, version 3.0, and where it all is difficult to see, where it all comes down to is this execute block. Execute means we are producing, we are executing. So you start here, you go through it, your whole batch, and when you're done, you're back here. So this is, let's say, the normal process. So then you got two waiting loops, one waiting loop and one waiting loop. One is there's something in the machine wrong, and the other one is we are waiting if it's a packaging machine. There are no products to be packaged. So the problem is upstream. Yeah, and then there are all kinds of errors and aborting and all kinds of interactions that you can have there, and that's here on the bottom. And it brings you back into the normal operational flow. So at the end of the day, it's very easy to ask, to get an overview of the machine, how many products did we package, and if we didn't package, was it problem in the machine or was the problem upstream in that sense? Yeah? And those are the core essential for your overall equipment efficiency. Now, such a state diagram you can map relatively easy to environments, especially if you use a language called sequential function charts. That's part of the IEC standard. It gives you a graphical overview. If we really start mapping this, you see these states. I hope you can read it a little. Stopped, resetting, idle. So this is the normal loop in the production. Here's the execute. And these are all the error conditions, because always in software you have more problems with the error handlings and all special conditions than with the loop. The loop is simple. That's straightforward. So you get everywhere this aborting, aborted, and getting back, cleaning, or stopping. And you get that with every cycle, and even in the cycles you can have those cycles. You never know what happens there. So you will see that there's here still underneath a program there. But you very easily can see where you are and if something special is going on, why, what happened there, graphically form. Like said, sequential function chart SFC is part of the IEC 61131-3 standard, and that's a worldwide standard, and that deals with the logic, the programming languages, the methodologies too. Yeah, so it provides structuring, decomposition, and it's the basis for reuse and less training if it's well implemented across the different systems, which it is nowadays. So we start with this logic. SFC is here, function block diagram, instruction list ladder diagram, the current languages. And we took the concepts of IEC 61131 as the organization PLCopen, and we added motion control functionalities to it. So we merged logic and motion onto one platform. And that helps tremendously in the different environments. Now, the nice thing is, we identify the function block, we give it a name. On the left side, in the graphical representation, you see on the left side the inputs with the data types and the outputs names with the data types. What's inside is that it maps somewhere, let's call this a move absolute. You expect that the axis or the machine will move to an absolute position. What's hidden underneath is, of course, an interface to the drive, motor, encoder, and some kind of feedback there. However, the function block looks the same if you have this an intelligent drive, if you have a dumb drive, and you go with the pulse width modulation directly onto the power stage of the drive, and you get your encoder signal back. Move absolute is move absolute, independent of the underlying architecture. That's what we call the encapsulation data hiding there. So you can think about a program, starting an application program. You can create functionalities on a higher level without having to know at that stage on which hardware it will run. Because in the end, it looks the same. Move absolute is move absolute. Just calling a different library. So somewhere in your name there will be a different extension referencing to the architecture that you want, the technology that you want underneath. But from a philosophy, from the starting of the application program, it's all the same. Based on this philosophy, we created a whole set of specifications. It took us quite some time, to be fair. So it started with part one, function blocks, then we needed extensions. Those two are now merged in an update because there was just a historical difference there. User guidelines we are now updating, will be published very soon. Part 4, coordinated motion, deals more with the, let's say, the robotics area. You start grouping of axes to make sure you can move a group of axes. Homing procedures, very important in every machine. But with these building blocks, you can create your own dedicated homing procedures per machine, per axis, per whatever. Part 6, fluid power, deals with mostly the high hydraulics parts, so it gives the same look and feel to the hydraulic valves and motion there. Although, of course, the content of the function block will be completely different. But move absolute is move absolute, even in a high hydraulics world. This will be specifically used in the... there is another button here. I just wondered where's this button for. Now I know. It will be specifically used in the mobile high hydraulics, so the large machines that are, well, looking for your garbage, taking your garbage, but also all the machines working on the land in the art, agriculture, the combines, tractors, all those issues. We have over 30 companies now certified for these function blocks, meaning they took the specifications and converted in their products to a real implementation, a working environment. Some words to the PLCopen guidelines. There will be the update. There's now a version, but there will be an update. And in this update, we try to simplify it more than we had before. So there are a lot of examples on how to create your own user-derived function blocks, for instance. And this is one example that we start with, is the labeling, where you got two conveyors, there's a product on it, think about a chocolate bar or whatever, and you want to put a label on it from a certain distance here, and a sensor distance, and it's moving. Now, if you convert that to a program, without having to know which kind of hardware, which architecture, if there's a bus, yes or no, it's running in the drive, I don't know, but the program can look like this. You got to move velocity to move all the axes here, those, and you got to move relative to put a label on under certain timing conditions where it is, and the timing condition, of course, coupled to the velocity of the move velocity of the belt going on. Very simple, very transparent, independent of the underlying technology. Well, if you start moving, we got to think about the safety aspects of any machine. That's according to the new guidelines there, the new laws, I would say. So we also took all the different safety specifications that there were, and there are a lot, and we took the graphical representation and created a set of function block, reduction in programming language, what is allowed, what is not allowed, to make sure that your certification of your machine goes much, much, much quicker than it used to be. So it's really the basis to make sure we don't spend too much time and too much cost in the validation of any production machine there. This also gives you the possibility, and that's very important, to include safety from the start on of designing a machine. Safety should not be something that you put at the end of the road. Oh yeah, we've got to do something on safety nowadays. Let's do something. If you include it from start on, it will impact your machine, and it will save you overall money there. And the concept will be much safer. So, also that's a suite of specification, it's not just one. We started with the concepts, user examples also here. Extensions, we needed more than that. We are now finalizing in a month, I hope in a month, the extensions dedicated for presses. It's not so much packaging, but it's the presses, what you see with car manufacturers, but also with a lot of other issues. They have some dedicated safety features around it, because there's interfacing to people much more. And we got a separate document on logic, motion, safety, how it all combines, because where do I start now with all these specifications going on? Then we have a cooperation with the OPC Foundation, which is holding now presentations on the other side later on. And with that one, we try to create the communication. It's based on the newest technology that OPC Foundation put on the market. It's called UA, Unified Architecture, A unified architecture has a client-server architecture to communicate. And so OPC UA specifies how to communicate, how to do an application session in a secure channel, so security is included. And that's very important nowadays, of course, as you start connecting all these devices. And we specified what is the information, what do we want to communicate, and how to get access to it. So that, if you want to know more about the details, I will be later on the other side, although things are going on here also. The essence is that we make it very transparent. So you really look into a controller that has a UA server. The compiler has done some additional information, and that takes care that that you can call it all by name. So I can ask which controllers do you have, which CPUs are there, which programs are running there, which function blocks does it use, which user-derived function blocks does it use, what are the inputs, what are the outputs, what are the names, what are the data types. So, and if I find such a parameter, I can say if that one changes, I want an update on our system. Very transparent now. Even if you do not know the names, you can scan in the online controllers, running controllers. So, transparent access, less engineering time in the overall control systems. We had one example, a live demo on the Hanover Fair last year, where the company SAP drilled live into our systems and took the value where the parameter was unknown to them before, but they knew it was in the system. It took them 10 minutes to build the connection and get the updates into their system. That's what we call transparency. Two systems that do not know each other. A little bit to the future, we are now working on something that we call the machine-to-machine communication. So we build client servers in the controller both. So any controller can talk to the other controller. The controller has a client, the other has a server. And we are creating function blocks to set up these channels, these sessions, and make sure that we can do that in the correct way. We hope that this April we will show the first results of this one. This is not the far future. This is how we are doing that now. We also are working on some naming conventions. If we do these kinds of things, it's very nice to know what the variable name is. So that's part of the PackML machine language. It's called PackTags, and that makes it even easier to connect these two worlds. If I've got an MES system somewhere that has the OPC UA server, I got a controller that has the OPC client upstairs, a server in the controller. That has the additional information being the modeling from PLCopen. Then if we have these naming conventions, then it gets very easy to find these. Yeah, so out of the box, plug and play. Versus plug and pray that we had in the past. Okay, so what does this all bring? This combination of PLCopen into the OMAC PackSoft. The logic and the philosophy is there in IEC 61131. PLCopen motion control for the motion start, safety as the basis for the safety functionality. That has nothing to do with the activity on safety, that does more the networking. How do we get the data across? Will be a separate presentation. OPC UA for the high-level communication, not to the drive. That is completely other networks. It's a little bit too slow for that one. And so this is how we see the merge and how we want to do it. All kinds of graphics to it to make sure that you understand what we are doing and you recognize them, of course. That's all from my side at this time. Any spec you can download, check on the website plcopen.org.